In this video, we're going to interpret graphs of parabolas to find things called the minimum and maximum values, as well as to use those minimums and maximums to solve problems. When looking at the equation of a parabola, you can immediately tell whether one has a minimum or a maximum, meaning this is to say, will it have a does it have a smallest possible value or does it have a largest possible value? Just as a quick sketch, if a parabola, all parabolas are like U's, whether they're right side up or upside down. So in order to have a minimum, what does that kind of have to sort of look like? I think that sort of kind of has to look like, I don't even need axes really. I think it's got to look something kind of like this. If it's going to have a smallest value, it's going to have a lowest point. So parabolas that have the lowest point have to look something like this. And these sorts of parabolas are right side up. These are like our regular right side up looking parabolas. These are parabolas whose leading coefficient is greater than 0, or the value of a is greater than 0. Whatever is multiplied to the x squared term has got to be positive. If a parabola is going to have an uppermost value or a maximum, that means that they have to, the only way for that to happen is for them to be upside down. A parabola like this does not have a maximum value because it just gets bigger and bigger forever. No matter what point you choose, you'll always get a point that's bigger than that. So there's never a biggest point. But you can get a biggest point if it's upside down. If it's upside down, it'll have a maximum. And for it to be upside down, we need to reflect that parabola upside down. To reflect, we multiply the leading term by a negative number. So we want the leading term be 0 for max. So right away I can tell that this function, that this parabola has a minimum, because this will be a right side up parabola, and this one has a max because it's flipped upside down. It's upside down parabola. This one has a max. And we can check that in Desmos just to be certain, to make sure we know what they look like. So maybe this first one, 2x squared minus 16x plus 4. This parabola is definitely opening right side up, and it definitely has a lowest point, so it has a minimum. What is that value? We say that that value is just the y coordinate of the vertex. So you can either find it with the formula that we saw in the previous video. You can find the x coordinate of the vertex by using negative b over 2a. Once you know the x coordinate of the vertex, you can plug in that x value into your function to find the output for the y. Or since you've got a graph calculator, you've got a graph calculator Desmos, let's just find the vertex on here and we'll just state whatever the y coordinate is. And on Desmos, that's easy. I just click on my function and I click on the lowest point. And the axis symmetry is x equals 4. Don't care about that in this problem. We do care about what is the value of the minimum. What is the lowest output this function ever gets? That lowest output is negative 28. So the minimum is negative 28. That's the smallest output. Conversely, we could find the maximum of this point because it has an upper point. I'm not quite sure what it is, but if I use Desmos to graph it, we can just click on that vertex and find the y output. So let's graph that. I'll come back over here. Let's clear out this graph, and let's graph minus 4x squared minus 24x minus 19. We'll drag the screen to get this in view. And as we stated from the equation, we knew it was going to be an upside down parabola because its leading coefficient is negative. What is that maximum value? What's the highest value? It's this point up here. It is the y coordinate of that vertex. So the maximum is positive 17 because the y coordinate of the vertex is 17. we'll often use this sort of thing if in a question about a projectile, like a thrown object or an object that's moving through in flight or something. We'd like to often a common question to ask is how high is that object get? How high is it thrown? What's the highest or lowest point that the thing ever reaches? If you're throwing, in this case, we're launching a water balloon in two different ways. The first way is a function that's modeled by this equation. F of t equals negative 16t squared plus 80t plus 5. Represents the first water balloon, t seconds after it's been launched. The height of the second water balloon, we don't have a function, but we do have a graph of its path here in the second water balloon. And the question is, which one of these two went higher? So we'd like to be able to answer the question we don't know. We'd like to be able to somehow compare the two maximums and decide which one's bigger. I don't know exactly what the maximum of this function is. It looks like it's somewhere around here. Maybe I'll mark it in red. It looks like it's somewhere around here. And I don't really know its exact value, but I do know that it's bigger than 25, 50, 75, 100, 125. It looks like it's something bigger than 125. So what we'd like to do, I think, to solve this problem, let's find the maximum of under the first way we threw it, under this first function, and we should be able to hopefully relatively compare them. And if they're really close, then we'll have to maybe make an estimate or look at another approach. But let's start by graphing this. So I'm going to clear out my old graph, and let's graph this function. That is, and again, Desmos and usually likes x is better than any other variable. So I'm going to switch the t's to x's. Negative 16x squared plus 80x plus 5. And I'm going to have to zoom out, it looks like, to try to find the maximum. And, well, I can find the maximum here. It's right here it has a maximum of 105. And let's record that. Looks like the first, so from graphing, the first balloon is 105 feet. It looks like the max of the second water balloon is more than 125. Something a little bit more. So if the question is which one went higher, so the second definitely went higher. Went higher.